Continuous random variables. An example is length, time, height, etc. Things that are not finite, not set. Different to discrete. Discrete was, I saw 5 red cars. You cannot say, I saw 5.5 red cars. Okay, it's a set amount. Continuous, it's not exact. Now, because I was bored, I went around and measured 75 adults' nose lengths. And the results were shown here. How exciting. Look at determining the probability between 42.5 and 47.5. So, what is the probability, or what's the frequency? How many had between 42.5 and 47.5? There was 21 that had that many. Probability of the thing we're trying to chase, x, between these two is the frequency of x between these two. So that's what the little f means, frequency. What do you think the notation is for all frequencies? Sum of frequencies. That's a bit messy, I'll try and fix it up. The frequency of between those two, like you said, 21, and the total is 75. Okay? Pretty simple. What about less than or equal to 47? Add up all the ones along here. Those are all less than 47.5. Quick maths, what are those? Added together creates 2 plus 5 plus 17 plus 21. 3/5. Quick maths, which is 60% chance we're going to find a person that has a nose less than or equal to 47.5 centimeters long. Shall we test it? Start measuring your noses. Shall we try some calculus now? So this is the calculus part of this. So if we look at a function like we just did with the noses, we can turn this into a function. So if we look at all the rectangles, we can make an approximate function. We make them infinitely thin and we plot a curve. So you make the continuous intervals smaller and smaller until you get a curve. The curve describing this data is called the probability density function. You're probably going to get sick of these. They have the following functions. It is positive for all x's. The sum of all of those in there sum to 1. So between negative infinity and infinity, and the area under the curve gives us the probability of those values. All right, let's try another example. All right, let's sketch this function. What else are we combining? Piecewise feast, available at KFC. So let's sketch the graph. So it starts at x equal to 1. So if we sub in 1, we will get 0. I probably should put the axes labels. So here, x equals 1. The function, if you sub in 1, equals 0. Sub in 2. Function is equal to. Sub in 2 is equals 2. So it looks like this. All right, bit of tricky calculus here. You don't actually have to use calculus. So it doesn't say to use calculus, so you can just determine the probability by finding the area under the curve. Yeah, it's not actually asking you to find the probability. It's just asking whether it's a probability density function. So what makes it a probability density function? I said it a few times. So is that true? What's the other thing we have to find? So the probabilities should add, or the area under the curve should add to. So let's do good old triangle. The area of the triangle is 1 times 2 divided by 2 is 1. So all the x's greater than 0 and the area is equal to 1. Therefore, it's a probability density function. We can also do this. I'll just show you the calculus way anyway, even though it's not required. It's going from 1 to 2, and it's this in terms of x. So integrate, you get that, and we're doing it in terms of, let's see if it works this time. Sub in 2 minus sub in 1. What do you end up with?